Hello there, this is Wellington with PX5, and today I have a special guest, Bill and me. Bill, would you like to introduce yourself?
Hi, I'm Bill Lemieux of PX5. I'm one of the founders of it.
Thanks for being here, Bill.
Oh, my pleasure.
All right, and today we'll talk about a recent blog post in which Bill makes the case for a wide adoption of POSIX Pthreads as the standard in the RTOS industry. So in this video, we'll run through the problems that comes with the multiple APIs in the industry, the negative impact that is causing, some potential solutions, and maybe a path to get into this industry standard. All right, so you might be thinking, as an embedded developer, why should I care about this, right? And when we look at the current situation, we find that over the past decades, every new RTOS which came into play also brought a new API surface. Some were good, some not so much. So regardless, what we have now is a plethora of APIs which represent potentially a negative impact in the industry. What are your thoughts on that?
Well, yeah, there's about, if you just look at Google search, just do a Google search and you'll find about 100 different RTOSs, out there. Just crazy. I didn't even know there were that many. And most of them have their own distinct proprietary API. And all of their users, have to learn and implement that API. And boy, it's just a huge mess, especially as we get later into this discussion about moving around to different platforms.
Mhm.
Software is just hard to manage.
Oh, absolutely. Yeah, so thinking of what is this negative impact in the industry? So we imagine that you adopted the RTOS X that comes with the API X and you have your application based on it. And after some time, new MCUs are now available with features you're looking for, but the RTOS X you adopted does not support them, only RTOS Y. So now to move from RTOS X to RTOS Y is very likely you have to rewrite your whole application. It's really, you're kind of stuck there because either you're going to be investing the time and the money to move there, or you're limiting your product evolution, right? So this, Bill, this can be seen as some sort of lock-in, can it?
Yeah, it can be a huge lock-in problem. Now, some developers will abstract the OS with their own layer,
Mhm.
their own minimal layer of OS services, and then they put the underlying RTOS API in it, underneath and abstract it so they can try to move around a little bit better. The overhead of that is pretty substantial, and usually, when they do the abstraction, they don't get the full power of the RTOS either. They're trying to do a minimal subset of it. The other issue too, Wellington, is
Hmm.
um, some RTOSs disappear, or some companies stop supporting RTOSs. So now you're using API X from RTOS X and it's gone.
Mhm.
So now what do you do? So now you're kind of forced into this rewrite situation
Mhm.
because of the lock-in on the proprietary API.
Wow. So it's a worst case scenario, right? Not only you're locked in, but you're locked in with, an out of date RTOS.
Yeah, yeah, and you just don't, with 100 of them, you can guarantee that not all 100 are going to make it.
Absolutely. So another point I had here, Bill, with regards to this negative impact in the industry, would also mean that, yeah, even if you decide to move to API X to API Y, so moving from one RTOS to the other, that also means that we're going to have to spend the time to train all of our developers, so which also incurs in, the money, both in terms of how much it costs to get there, but also in terms of the time the developers will sit in a classroom to learn all about this new RTOS. Have you seen this being an issue for companies in the past?
Yes, unfortunately, I've written 3 proprietary RTOS APIs myself, and
Mm.
even outside of moving later, the initial development, when companies first pick an RTOS and start using it, if it's a proprietary RTOS API, they have to spend a lot of time learning it. So, my experience in the past was the most significant part of training for a new customer was learning the API. And as we say here, that costs time, which impacts the schedule, and also, everything costs money. Having your engineers, learn an RTOS API from scratch costs money, and also, you know, there's a lot of mistakes made. When you first learn something, you don't really know it, and so as time goes, you'll learn it better. But in the early days, you might implement something wrong or incorrectly, and that could cause quality problems for the product.
Of course, it's a learning curve, right? You learned, but then until you become proficient and you really can take the most of the API, yeah, that will take a while.
And especially if you have multiple, if you have multiple RTOS APIs or multiple APIs in your multi-threading environment, that gets even harder because, you learn one and then you unlearn it when you learn something else, and, it can be a real mess.
Absolutely. In case your customer application needs to run on both microcontrollers, like in this case your Cortex-M and similar, and also run on NPUs, Cortex-A and similar, there is a high likelihood that they will have to create and maintain separate code bases. So one version of the application to run with one type of RTOS for MCU, and another one for the separate MPU-like application. Right, so that also looks like a grim scenario to have, doesn't it?
Yeah, this is a real mess for a lot of companies, and has been for some time. If you look at architectures like Xilinx, for instance, a Xilinx platform, where they have a hardcore or quad-core Cortex A53 coupled with a Cortex R5. The R5 is traditionally an RTOS, type environment, and of course the A53 is typically, something like embedded Linux. Having to have separate teams or separate firmware code bases, and not being able to share any code, I mean, that's just a real mess for what is a good subset of the embedded development, this multi-core, embedded Linux with RTOS scenario.
Mm-hmm. Yeah, that makes sense. And that goes for the whole development life cycle, right? All the way from creating and testing and the CI/CD pipeline, having to maintain twice as many, it's a lot of overhead, right?
It sure is. Yeah, it's a mess from start to finish, and even later on, as the product evolves and goes into more of a maintenance mode, you still have to deal with this.
So thinking of solutions for these issues and looking if they're any good or what should we do, I capture at least a couple here that I like to discuss, Bill. And the first one is this idea of having adaptation layers, right? So creating these adaptation layers here for the different API surfaces that would allow the application to only have to deal with these high-level adaptation layers. This looks like it would increase, overhead, complexity, or problems overall, right? But there's more to it, doesn't it?
Yeah, this is kind of similar to what I said very early on, where the way some companies try to deal with this in the past is they would abstract the operating system. So
Mm.
they would make their own primitive subset abstraction layer of the RTOS. And then inside of that, they would actually make the native RTOS API calls. While doing that, you increase the overhead because you have a whole nother function call there. And in an RTOS scenario, that more or less doubles the overhead. In terms of RTOS vendors have taken a similar approach where they've added adaptation layers,
Mm.
to get to standard APIs, but those adaptation layers they lay on top of the RTOS API. So it's a whole nother function call, and even worse, a lot of times the adaptation layer is using things like mutex for mutual exclusion while it's inside the core processing of the API processing. A little too many processings there, but the idea is it's using an API call just for protection. So that's going to at least triple the overhead of the native RTOS API implementation.
Mm.
So that's a big problem. And then the other thing is most of the time the the RTOS adaptation layers are meant just to help get some compatibility. They're hardly ever functionally safety certified. They
Mm.
don't generally have the same quality that the rest of the RTOS code has. They're not 100% branch tested, those kind of things. So you also have that issue as well as the overhead, and just increased complexity and memory size and everything else. So it is a kind of like a short-term band-aid, but not a really long-term solution.
Looking at all of the problems, right, and the attempts to solve, for the shortcomings of not having this standard APIs, as I was looking through your blog post, it really looked like, until now we had this negative impact in the industry, right, that's causing a bunch of problems. But it looks like the answer was there all the time.
Well, it's funny. There's been attempts in the industry. ARM with its SimSys RTOS API, had an attempt to try to standardize the RTOS APIs across the industry because they saw the same problem. But the problem with that is that it's really just another proprietary API that you have to learn, and it's also a subset of what is typically a meaningful RTOS API. So when I was looking at this, after I left Microsoft, I was looking around. I go, well, it's funny because the standard API is already there. The IEEE POSIX Pthreads standard has been out for many years, and even more amusing is embedded Linux has that API and promotes that API. So roughly 70% of the embedded designs today are embedded Linux. Now those are mostly on MPUs, so higher end embedded processors, but still that tells you that there's a lot of people with a lot of knowledge already, in hand with POSIX Pthreads. So there's no real reason to reinvent another API. The POSIX Pthreads API is what we should all be using.
Yeah, and I remember I actually still have this with me. I have the book, right? And yeah, of course, we learn Pthreads every time we're talking about multi-threading in college. This is what you learn.
Yeah, I mean, it's really good, and for some things, it's even simpler. Like for instance, if you look at a pthread create API call, it's the simplest way to create a thread out of all the RTOS APIs. So there's some simplicity advantages in it as well as being industry standard.
I covered that on how simple it is to create a thread with PX5 RTOS in a separate video. I'll make sure to leave the link in the description of this video as well. Okay, so thinking in terms of how the Pthreads could help with all of the challenges we were mentioning before, which really makes sense in terms of coupling these real hard time capabilities with this industry standard API that could potentially represent the best of both worlds for embedded developers. How do you see, these two words combined to help out on solving all of the problems we pointed out before?
Well, see, on the MCU side of things, we're really tight with memory constraints or processing constraints. So, that's where we get back into a little bit of the adaptation layer. Those just aren't going to work. Many MCU-based designs can't afford another, doubling the overhead or doubling the memory size. So it really gets back down to, getting the RTOS industry to migrate to Pthreads, and have native implementations where the API is exactly what is implemented by the RTOS, that functionality, that API. And if we do that, then the Pthreads API is completely viable on MCU class devices. And then devices that have that API and applications written for it, they can share code between embedded Linux, between any other RTOS that has the Pthreads API. The code, companies that make software can really protect their software investment by standardizing on Pthread API.
It will make it easier for anyone to learn how to use these RTOS APIs as well, right?
Yeah, right out of the gate. A college student, coming into his or her first job, will be able to create threads and do multi-threading. Right on. Whether it's a small device that has 64K of memory, or whether it's a big MPU device running embedded Linux. It's nice to be able to use the same thing on that whole spectrum of devices.
For folks who want additional information about how PX5 RTOS is actually implementing POSIX Pthreads, make sure to try and run our samples. There's also an entire chapter on the PX5 RTOS user guide dedicated to the use of POSIX Pthreads. There's also this blog post from Bill, the one I've mentioned earlier in this video, the link down below to that. And Bill, any comments on how PX5 RTOS is actually embracing POSIX Pthreads?
Yes, our new RTOS, the PX5 RTOS, one of the main value propositions is the native implementation of POSIX Pthreads. So we believe we can be the fastest, smallest RTOS and yet still have the POSIX Pthreads API. So so that's one of the main value propositions, and we lose our lock-in. I mean, in the past, my RTOS has had their own API, and so once customers would use them, then they were kind of stuck. But with PX5 RTOS, we don't have the lock-in, but we feel we're doing something better for the embedded industry. So we think the greater good is the way to go, and we can offer the same small, fast, advanced technology with the PX5 RTOS. Now, we do augment it. We have a set of additional APIs for event flags and other things that embedded customers typically want in an embedded RTOS. But those are all well identified with a PX5 prefix, so they don't get confused with the POSIX API.
Sounds like something worth taking a look. For anyone who wants to know more and how to get started with PX5 RTOS, make sure to check our website at px5rtos.com. You can always email us with questions, request for information, or quote at info@px5rtos.com. Bill, it was a pleasure having you here today. Thank you for your time, and thank you for being here with us.
Thanks, Wellington. Thanks, everyone.